Hi Quantum Universe followers. I am so excited about this collaboration, and I've been reading all your questions in the comments of the Quantum Universe post, and I'm super excited to see that there were more than 500 comments and questions on the post. So I'm really happy to be here with you today, and I'm going to answer 3 different questions. The first winner question is from HRU161, and they asked about whether or not it's true that Earth's days used to be shorter. So they specifically asked, when the dinosaurs were around, is it true that Earth's days, so the time it takes for Earth to spin around itself one time, was actually only 23 hours? And the weird answer is that yes, that's very true. So just to clarify, this isn't time changing. This isn't anything fundamental about time changing, but it's actually just fundamentally about how we measure time here on Earth. So how long it takes Earth to spin around itself one time is how we define a day, and that is actually slowing down over time. So that might sound really weird, but the reason that's happening is actually because of tidal forces between the Moon-Earth system. So you've probably heard about how the moon exerts a tidal force on Earth's oceans, and we have this kind of elongation towards the moon, causing tides on 2 sides of the Earth at the same time. And actually what happens because of these tides is that there's friction that makes Earth slightly slow down in its spin around itself. And then because of something called angular momentum conservation, which is a fundamental thing in physics, that will lead the moon's orbit to change slightly and also to move further away from us. So actually, the moon is every year moving about 4 centimeters away from Earth, and that's quite weird, right? So it's the same amount of growth that your fingernail has, basically. So it's a very, very subtle change, but the moon is actually on its way away from Earth. And this will continue for about 15 billion years until a day on Earth is the same amount of time as a full orbit of the moon around Earth. So basically, when a day is the same length as a month, this process will stop. And one thing I really like about this problem is that solar eclipses, total solar eclipses, where the moon fully covers the apparent size of the sun and the sky, actually won't be able to happen once the moon is far enough away. So it's somewhat of a coincidence right now that we have this perfect alignment between the apparent size of the moon on the sky and the apparent size of the sun, because that didn't necessarily have to be true. The moon is obviously a lot smaller, but it's also a lot closer to us. So I thought this question was super fun because there's a lot of physics going on, and thank you so much for asking it.